Okay, so I am going to be, through the miracles of technology, talking to you in this hall, but actually controlling things via Zoom. So we'll see how that works out. I got a load of slides covering different topics. We will run out of time, I think, before I run out of slides, so I'm going to be relying on Simeon to come on stage with one of those little hook things and drag me off. However, this presentation is where we raise our eyes from where we currently are, which we've been thinking about quite a lot in the last few presentations, and think about some more, I don't want to call them theoretical, but some more blue sky sorts of things about the ways in which Mojaloop could evolve to cope with some of the issues that are going to arise when we start to look at how we do cross-border and inter-scheme payments. We will be hosting, sorry, when I say we, I mean Cece, Sam, Cummery, and I will be hosting a breakout session in this room on Friday morning when we're going to talk about much more focused issues to do with cross-border and inter-scheme payments. Okay, I would ask everybody who might be interested in those sorts of issues to please attend the breakout session where we, as I say, we'll be talking about more detailed initiatives that we can start on in the next PI. So I'm really going to talk about three different topics. First of all, maintaining message integrity across schemes, then settlement as a service, and finally, if we have time, I'm going to talk about identifying parties in cross-jurisdictional payments. So, without further ado, maintaining message integrity across schemes is really a report out on some work that we at the Mojaloop Foundation have been doing with the Interledger Foundation. Now, the Interledger Foundation has a set of protocols that implement a peer-to-peer network for the transfer of financial information. We've always been pretty close to each other, not least because their way of signing their transactions is the same as the one that we use in the condition and fulfillment in the Mojaloop space. But there are significant differences, and to some extent they've grown apart from each other, the two implementations. So one of the things that we've been engaged with in the last 6 months to a year is trying to put them together in such a way that an institution which is using the ILP protocol, which is now called the Rafiki protocol, it's a much higher level protocol than it was before, an institution using that protocol can talk to a DFSP in a Mojaloop system. And when I say talk to, I mean transfer funds to. Those of you who were in Kigali will have seen a demonstration by a very nice bunch of Mexicans from the People's Clearinghouse, and they intend to implement the first instance of this. So this is really a report out, as I say, on the work that we've been doing. Now, our original thinking, this goes back to, you would have seen this yesterday afternoon in Min's presentation. We've got an external DFSP, in this case using the Rafiki system. I'm going to call it a Zeno DFSP for quietness. It's got its own API. Then over on the other side, we've got a Mojaloop DFSP, which talks Mojaloop API. There's a Mojaloop network. And then in the middle, there's a cross-network provider. You will probably have heard that phrase in Min's presentation talking about what we plan to do in Kamesa yesterday. And what the cross-network provider does is it's got the Zeno DFSP's API, whatever that is, on one side, and it's got a Mojaloop API on the other side. So the external DFSP talks to the cross-network provider in Zeno DFSP. The cross-network provider talks to the Mojaloop DFSP in Mojaloop, and everything is fine. Cross-network provider translates between those two protocols. Now, there are some consequences which we don't like, consequences of this approach. First, it means that we can't do end-to-end verification of message integrity. Now, how we do that in Mojaloop is the person who originates a message signs that message with their private key and sends the signature along with the message. When the message arrives at the recipient has the public key for the person who sent the message. We're talking a bit more detail about this in a little while. But essentially, that means that the receiving institution can be confident that the message really came from the originating institution and also that it hasn't been modified in transit. Now, if I were a French linguistic philosopher, I'd be using terms like signifier and signified. Now, the difference between a signifier and a signified is the signifier is the word and the signified is what it represents. So if I say that's a chair, it's a chair. That's a word. If I were French, I'd probably say c'est une chaise. Or if I were German, I'd say das ist ein Stuhl. Different words, same concept. The problem is that the signature is on the words and not on the concept. So even though in the translation that the cross-network provider is doing, the concepts remain the same, the amount to be paid, the information about who is to be paid, all of that is still the same as it was, but they uses different words and therefore the signatures are not the same. Consequence of this is that the person who receives the message only gets the information from the cross-network provider, not from the original sender of the message. And that's true in both directions. Now, the cross-network provider settles on behalf of the Zeno DFSP, but obligations appear in the Mojaloop scheme as assigned to the cross-network provider, which in some senses is true, in other senses not, because they are obligations incurred outside the scheme. Now, when we started to think about this, we decided that what we would really like is something that improved on this model. So the standard cross-network provider used the Interledger Foundation Open Payments API, translation back and forth at the cross-network provider, and the cross-network provider settled on behalf of the Zeno DFSP. So as far as the switch and the Mojaloop DFSPs were concerned, they were simply interacting with the cross-network provider. Now, the improvements that we propose are like this. This is the original model. Now, we want the external DFSP to be able to talk more than one protocol. Mojaloop DFSP can carry on talking Mojaloop, and the proxy no longer needs to translate between the two protocols, because now you'll see on the left-hand side, we have an API which enables the left-hand Zeno DFSP to talk Mojaloop. And now the message can go straight through the proxy, which I'm calling now a proxy rather than a cross-network provider. And the signature that was originally appended to it by the Zeno DFSP is still valid when it gets to the Mojaloop recipient. So how does this process work? The Zeno DFSP issues a payment request, and it issues that using the Interledger Foundation Rafiki Open Payment API. So that's still Rafiki at that stage. The Open Payment API establishes a connection with the proxy, which also needs to be running the Interledger Foundation's Rafiki protocol. The proxy now responds to say which types of payment it can support. So we're extending, and the Interledger end, the types of payment that we can support. And one of those types is going to be Mojaloop. So it will support ILP, which is the original Interledger Foundation protocol, and it will support Mojaloop. It may be that in the future, we will extend that so it supports other kinds of payment as well. Sorry, when I say we, I mean the ILF will extend it, so it supports other kinds of payments as well. Proxy returns Mojaloop, and this means you can route payments to me using the Mojaloop protocol, but not any other protocol. Now the Rafiki instance knows that communication has to use the Mojaloop protocol, And this decision is encapsulated in the Rafiki interface. So the original sender, the Zeno DFSP, is still talking Rafiki, and the payment manager, which is encapsulated in the Rafiki component, is converting those calls to Mojaloop FSP IOP calls and sending them through properly signed. Now, obviously, that relies on resource correspondence between the Open Payments API and the Mojaloop API, by which I mean it has to have the same endpoints. It has to have, for instance, it has to support the two-stage protocol in which we have the agreement of terms followed by the transfer. But we think we're okay with that. Well, that sounds good. Now we can attach a signature to its messages, and the FSP IOP source parameter will be set to the eventual, FSP IOP source will be set to the eventual originator, not the proxy. Pardon me. The proxy passes the messages through unmodified, and the recipient can check the message was sent by the Zeno DFSP and that it's not been modified. Oh ho, that almost works. Question is, how is the recipient, the Mojaloop DFSP, going to check the bona fides of the message? Now, I'm going to talk a little bit about public key infrastructure. Technical people, you can go to sleep during this because you know it all already. But just in case there are people who don't understand how public key infrastructure works. How it works is a DFSP asks a certificate authority for a certificate. Certificate contains two things, a public key and a private key. The public key, hence its name, is shared with every other participant in the scheme. And attached to it is a reference back to the certificate authority which issued it. So the receiving DFSP can check that the certificate authority recognizes that that is a key that is issued. Now, the DFSP signs the Mojaloop message using its private key and sends it to the recipient. The recipient signs the message using the originator's public key. So now we've got two signatures. They're comparable. And by what I mean by that is they can't be the same as each other. Otherwise, you might as well have not difference between public keys and private keys. But there is a way to understand whether signature produced by a private key and a signature produced by a public key are equivalent to each other. If the comparison succeeds, then the recipient knows, as I say, that it really was sent by the originator because the originator's public key signature succeeded and that the message hasn't been modified, which is where we want to be. A little bit more technical stuff. Now, the recipient of the message needs the sender's public key to make this check. In Mojaloop, the scheme's relation of trust allows keys to be shared around the scheme. It's not a problem. But we don't, I think, want the Zeno DFSP to have to register its key or its certificate with the Mojaloop scheme. It may have no idea what the Mojaloop scheme is. It may have its own certificate authority. We don't want to rely on that or make it a condition of joining. We want the relationship to be between, the relationship of trust be between the Zeno DFSP and the proxy, not between the Zeno DFSP and the Mojaloop scheme. Now, as I said, the public keys have two components, the key itself and the reference to the certificate authority, which issues the public key. We propose to get around this by adding a new resource to the Mojaloop API, which enables a participant in a Mojaloop network to ask another participant for a specified public key. So a DFSP receiving a message from a Zeno DFSP, for instance, can ask for the Zeno DFSP's public key, and vice versa. In both cases, the message containing the public key, when it's returned, is signed by the proxy. The proxy is trusted by the DFSP because they both belong to the Mojaloop scheme. And it's trusted by the Zeno DFSP because it and the Zeno DFSP are in a pairing relationship, as they call it in the ILF world, with each other, and that enables them to exchange payment messages with each other. And that replaces, for this solution, the need for verification of the certificate authority which issued the public key. So the way it works is, we've got a trust relationship on the right-hand side between the Mojaloop DFSP and the proxy, and another trust relationship on the left-hand side between the proxy and the Zeno DFSP. Public key goes from the Mojaloop DFSP to the proxy, and it goes, and then it's re-signed by the proxy and goes back to the Zeno DFSP. And because the Zeno DFSP trusts the proxy, it will allow that. So now, the Zeno DFSP can sign its messages to participants in the Mojaloop scheme, and participants can verify that those messages are good. A Mojaloop participant already signs all the messages it produces, but now they can be verified by the Zeno DFSP. And the switch can record conversations between the actual participants. So that's how we figure that is probably going to work. We had hoped to be in a position to demonstrate this at this convening. However, oh no, sorry, I'm not going to say this. However, things did not go as quickly as we had originally planned them to do. So we are still waiting for an actual demonstration of this, but we're reasonably confident that this will work. Okay, so that's that side of things. 20 minutes, okay. Now, the next thing I want to talk about is an idea that we are currently calling settlement as a service. And this came out of a set of conversations that I had with Arun J. Katakam of UNCDF, when we started to think, could we imagine a service that would enable settlement to take place between people who didn't belong to the same scheme, or perhaps to any scheme at all? Now, if this is another problem that ILF has. They're pretty good at recording transfers and trusting each other about them, but they do this at the price of not having any concept at all of how those transfers get settled. So there, we think, are going to be kind of interested in that. And it may also be the case that when we come to think about how we want to connect Mojaloop schemes with non-Mojaloop schemes, we will be interested in managing the settlements between those schemes in, shall I say, creative ways. So let's have a look at how this works. We've got a message corridor. There's a Mojaloop scheme on the right-hand side. There's an instant settlement network, which I'll be calling an ISN down there. And the Mojaloop proxy and a DFSP attached to the instant settlement network have a relationship. They might be the same entity, or they might have some kind of trusted relationship. Then we've got a debtor institution, and that has a relationship with another DFSP in the instant settlement network. Got the customer over here. Now, what that says is that the Mojaloop proxy, like the proxy we talked about in the ILF example, needs to be a settling participant in the Mojaloop network. The debtor institution, in the same way, must have some kind of relationship with a member of the instant settlement network. And you'll notice that the message corridor at the top is completely independent of that relationship. That's a relationship of the kind that we've just talked about in relation to the Interledger Foundation protocol and its connections. So one of the things that we're doing here is splitting off routing of messages and verifying of messages from questions of the recording of obligations. Now, the ISN, we say, transacts in its internal denomination, which we're calling ISNC. It might be a stable coin of some kind. It might be a digital currency of some kind. It might even be a CBDC or an international digital currency. Anyway, how currency conversion happens in this scenario is like this. It's requested by the debtor institution. If they want to send in their home currency, then the debtor institution should decide what amount of ISNC it can purchase for that amount of local currency. But in any case, the debtor institution will denominate the currency conversion request in its as ISNC to target currency. So that says the conversion it wants is a conversion from the instant settlement network's currency to the recipient's currency, the beneficiary's currency. The proxy will act as the foreign exchange provider. We talked about that yesterday. And the conversion agreement takes the following form. The proxy defines the rate at which it will convert from ISNC, the internal currency of the settlement network, to the beneficiary's target currency. It converts the response to Moduloop's format and sends it back to the debtor institution. This will be denominated in ISNC, and the approval says, you must provide me with this amount of ISNC as collateral for my payment. The debtor institution now requests agreement of terms from the creditor institution using the target currency. So it says, I want to transfer this amount of your currency. It's relying on the agreement that it got from the proxy that a specific amount of ISNC will be converted to a given amount of target currency. From now on, all of the Moduloop interactions take place in the target currency. And the payment appears to the Moduloop scheme as a single currency payment. If the creditor institution imposes additional charges on the sender, then the debtor institution may need to requote to make sure it's properly understood how much ISNC it needs to send. But that's a wrinkle, an edge case. We're not going to spend much time talking about that now. Now, when we execute the payment, the debtor institution lodges the amount of the payment in ISNC with the instant settlement network. Now, it can do that by purchasing currency in advance or purchasing it at the time. It doesn't really matter which. So now the instant settlement network has sufficient liquidity to cover the transfer. And the request is secured with the condition, the Moduloop condition attached to the payment, and the public key of the proxy. Now we've got a new kind of liquidity check now. We assume that liquidity that we're currently checking is available for inspection. It's a static bulk amount, which is available to cover any transfer. It's guaranteed by the scheme because only scheme administrators are allowed to change it. And it's analogous really to a bulk purchase of currency via an FXP. For software as a service, we want to look at the idea of a payment versus payment check. Yes. Sorry? All right, that's true. I do mean settlement as a service. Well spotted, Mr. Bush. I just wanted to see if everyone was paying attention. So that's partly because a Moduloop proxy may be providing liquidity check services for multiple sources of inbound payments. There could be numerous external entities using this service to transfer funds into the Moduloop network. Managing those requirements, we think, will be difficult, might be risky, and hence expensive. And it would be more efficient if we could obtain confirmation from the ISN that it was holding funds for a particular payment, this payment, and provided we trusted the ISN, of course. So we suppose an agreement between a Moduloop scheme and an ISN, which supports a general trust relationship between the two. It's got to work like that. It can't happen any other way, I don't think. The liquidity check now works in the following way. The sending institution, as we've said, deposits funds. They might be direct or via a proxy member. It identifies those funds to the ISN using the condition attached to the agreed terms of the payment. The switch now asks the proxy whether it has the funds to cover that payment. The proxy asks the ISN, and it knows the condition associated with that payment. And also they are specific to that payment. The ISN is responsible for guaranteeing that this is true. So the proxy sends the ISN a challenge and a signature to that challenge obtained by using its private key. So now the ISN can use the public key it received from the debtor institution to verify that the challenge was signed with the correct key. So now the ISN knows that it's being asked to guarantee the transfer by the institution that the debtor institution said was allowed to ask that question. And that's equivalent to passing the liquidity check and reserving the funds, except that the proxy itself doesn't need separately to provide that liquidity. The liquidity is essentially delegated by an agreement to the instant settlement network. Now, when we come to complete the payment, proxy receives notification from the switch that the payment has completed successfully. It uses the fulfillment to request transfer of the funds, signs the fulfillment with its private key. Now, the ISN can verify that this is a legitimate request because it compares the fulfillment with the condition. That's a standard check that everybody performs to say, is this fulfillment a fulfillment to this condition? It confirms the signature of the fulfillment using the public key that was sent with the original transfer request from the debtor institution. And following verification, the funds are unlocked and they're directly available to the proxy. And these funds are in ISNC. It's up to the proxy now to make sure that settled funds are available in the target currency to support the process of settlement in the Mojaloop scheme. So that, we'll just see how that happens here. And that's all I have to say on that subject. Now, my question is, I've got a little time left, I think. Yeah, great. I'll get on with it. Unless anybody has any questions on either of those. No? Yeah? No? Okay. All right. So now I want to talk about identifying parties in cross-jurisdictional payments. Our motto is the old English phrase, let sleeping dogs lie. Meaning, of course, as you know, if there's a problem, there's no point in going looking for it. You might as well leave it for the moment until it comes and looks for you. But in this case, we want to say, let sleeping data lie. And this is an answer to, I think it's an answer to the questions that Joseph was raising earlier on this afternoon. Well, the objectives are, we want to allow the participants in an IPS. Okay. Should allow the participants in an IPS to be confident that the parties with whom they're dealing, the parties to the payment, meet the compliance requirements, and we don't want to share PII. PII is personal identification information. It's information that you can use to identify a particular party. It's defined in the EU's GDPR, yes, GDPR, General Data Protection Regulation, which says these are items that you have to be careful with. Shouldn't require the participants to be members of a particular type of scheme, or indeed of any scheme at all. And we want to retain the PII data in the jurisdiction of origin. You can see people are starting to run. Clearly, I should have included more jokes in this presentation. The assumptions that we have is that it's only PII data that needs to be kept in the country of origin. We assume a relationship can be established between the regulators of the jurisdictions to which the two parties to the payment belong, and that participant entities can reliably identify the state of the PII data that they held at a given point in time. And the reason for this is that this will result in people being asked, in a participant being asked, what is the data that you held about this person at this time? That is to say, at the time when this transfer was executed. It's not sufficient to be able to say, this is the data that I hold about them now. You have to be able to say, at this time, I held the data in this form. So the regulators then, they've got to agree with each other that the institutions regulated by each regulator are correctly regulated. So each regulator has to trust the other regulator is correctly managing regulation of the financial institutions. There has to be a mutually agreed terminology for items of PII in the two jurisdictions. That's probably not too much of a problem, but we need to make sure that it happens. If regulator A requires information on a customer of an institution regulated by regulator B, then they can obtain that information on demand through a route nominated by regulator B. And requesting this information imposes on regulator A the same responsibilities for the safeguarding of PII as are enforced in jurisdiction B. Now, when we look at how things work today, you've got DFSP A, which is regulated by regulator 1, and DFSP B, which is regulated by regulator 2. When there's a transfer, the PII requirements must be explicitly agreed by the two regulators. They're put into a document by DFSP-A, and that document goes with the payment instruction. And it fetches up in the creditor institution and any intermediaries like a Moduloop switch. That's how everything works today. If a regulator wants to see the PII, it asks the party it regulates, or perhaps the IPS if the party belongs to an IPS. So if regulator 2 wants to see information about that transfer, it asks DFSP-B, because DFSP-B will have received a copy of that data. Now, there are drawbacks here. First of all, the PII agreements must be agreed. The content is now distributed across multiple locations in multiple jurisdictions. This may violate data sovereignty laws, and in particular, privacy legislation like GDPR places a heavy burden on institutions which may not be very ready to carry it. In particular, small institutions receiving information. Let's imagine that someone in Paris sends a remittance to someone in Senegal, to a small MFI or a VSLA in Senegal. GDPR says that the responsibilities of that small MFI in Senegal are exactly the same as they would be for Crédit Lyonnais in Paris. So there's a problem there. We propose PII should remain in place at the owning DFSP. And the DFSP simply exchanges a warranty with the other parties that says, I've got this information, I will make them available to qualified parties on request. Regulator can request the items of PII associated with a payment, either directly or from an IPS, and it provides a public key which the responding DFSP can use to ensure that the information requested can only be read by the requesting regulator. So what happens is that the DFSP encrypts the information it sends to the regulator using the regulator's public key, and then only the regulator can read that information. It can be stored anywhere in transit without violating PII GDPR regulations. How that will work is PII is kept there. The requirements can be agreed ad hoc as part of the agreement of terms. A warranty is attached to the payment instruction, and that warranty is stored by the creditor institution and the intermediaries. If a regulator wants to see the PII, it asks the party that owns the PII, perhaps the IPS. And regulator 1 warrants to regulator 2 that they will ensure that DFSP-A's KYC processes are compliant. So how will we implement this in Moduloop? Well, relatively simply. So when have we got time for this? No, maybe we haven't got time for this. There's plenty of detail in the slides. The slide deck will be distributed. If anybody has any questions, I can take a small number of questions now. Alternatively, you can raise issues at the discussion group on Friday morning.